Hello and welcome to video 12 for Math 123. This is the first of 4 videos on the topic of geometry. This will be the last topic that we're covering. We'll have one video at the end on test taking techniques, but otherwise these next 4 will be the last of the material that you will be responsible for. So, this is on geometry. Let's talk about the most basic geometric object. And what do you guys think this might be? So you have what? You have squares, you have circles, you have lines. So what do we think it is? It's none of those. It's actually that right there, a point. So a point is the most basic geometric object. Technically, a point has no dimensions. So no length, no width, no height. Yes, if we draw a point, it looks like it would have some dimensions, but technically from a geometric standpoint, we say that it doesn't have any dimensions. However, it's the building block of all of our different geometric features. So next, we're going to talk about lines. So a point has no dimensions. Lines have one dimension. And this is length. So we talk about what's the length of the line. We don't talk about what's the width of the line, what's the height of the line, just one dimension. What's the length? And we actually have 3 types. We have a line, which goes on in both directions forever. And we notate that with the arrows on each end. We also have a line segment. So that's just what we would call a line, but no arrows on either end. So it just starts at one spot, ends at another point. That's a line segment. And then third is what's called a ray. And this starts at one point, goes on forever in some direction. Again, notated with the arrow at the end, indicating that it's going on forever. All right, from this then, we can build using these points. If we join 2 rays, so we have a starting point, a ray goes in some direction. Same starting point, going in a different direction. This point where they meet up is known as a vertex. So if I have 2 rays starting at the same location, that location is called a vertex. When I have 2 rays that are joined together, meeting at a vertex, they form an angle. And so you see that with these geometric shapes, we're starting at the most basic and just working our way up. So we had a point, that's our building block. Then we get a line. Then we get a ray. Now we join 2 rays together. That forms a vertex and an angle. So from the praxis standpoint, so technically, the angle formed by these 2 rays could be anything between 0 and 360. But praxis just mainly focuses on angles less than or equal to 180 degrees. And when we have an angle of 180 degrees, what we get is a straight line. So from one ray around to the other, this would be 180 degrees. That gives us a straight line. We have three classifications of angles. We have an acute angle. And this is less than 90 degrees. So 0 to just under 90, acute angle. We have an obtuse angle, which is everything greater than 90 degrees. And when we have exactly 90 degrees, this is known as a right angle. And these right angles have a lot of useful features for us, as we're going to see when we start figuring out things about triangles and so forth. All right, so those are angles, three different classifications: acute, obtuse, right. We have a couple other classifications. So we have what's known as complementary angles. And this is two angles that total 90 degrees. So if I have one angle that's 40 and one angle that's 50, 40 and 50 is 90, those two angles are complementary. And the second type is supplementary angles. And this is two angles that total 180 degrees. Whoops, that total 180. So, if I have one angle that's 60 and one angle that's 120, well, 120 plus 60 is 180, so those two are supplementary angles. And then we have adjacent angles. And as the name implies, adjacent, next to each other, so these are angles that share a side. So if I was to draw this, if I have this angle here and it's 30 degrees, and then this angle in here is 40 degrees, well, this one here, because they're sharing this side of the angle, these would be adjacent angles. They're next to each other. All right, and the last thing for this first video, and this will wrap up our information on lines. We'll start getting into some figures then. What we have, it's called a transversal line. And this is a line that crosses two parallel lines. So let's say I have, let's pretend these are parallel as good as I can draw them, and I have some line that crosses these two parallel lines. This line is known as the transversal line. Now, when we have two parallel lines and we have a transversal, a line that cuts through them, we get a lot of interesting features here. So let me label these 1, 2, 3, 4, 5, 6, 7, 8. So angle 1, angle 2, angle 3, angle 4, 5, 6, 7, and 8. So some interesting features here about these angles. First of all, 1 and 2 are what? They're supplementary angles. They form 180 degrees. Same with 1 and 3. They form 180 degrees. 3 and 4, 2 and 4, etc. So these numbers that are next to each other all are supplementary. They all form 180 degrees. Another interesting feature is in this situation, angle 1 is equal to angle 4. So the angles opposite each other on the transversal are equal. So 2 is equal to 3. Down here, 5 is equal to 8. 6 is equal to 7. Also, we have the feature, let me change colors here so we can keep it straight. So if we look at the picture, I have these parallel lines, this line cutting through, well, what do I notice about 1 and 5? They look the same, right? Well, it's because they are. 1 is equal to 5. 3 is equal to 7. 2 is equal to 6. 4 is equal to 8. In addition, as I said at the start, a lot of interesting feature about these. So look at the picture. What do we know about 3 and 6? Well, they look similar because they are. 3 is the same as 6. 4 is equal to 5. And also, 1 is equal to 8. 2 is equal to 7. And I'm not going to concern or require you to know that these have names like alternate interior angles, alternate exterior angles, things of that nature. But just know that when we have two parallel lines with a transversal, we get all these groups of all these groups of angles that are equal to each other. So if you have this on a test, it might be asking you, okay, if angle 1 is equal to, whatever, 25 degrees, what is angle 6 equal to? Well, we know that angle 1 and angle 5 are the same, so that would have to be 25. And we know that 5 and 6 form 180 degrees, so that would be what? 155 degrees is what angle 6 would be. So we can use these properties, these geometric properties of parallel lines, transversals, to figure out angles that might not even be anywhere close to each other, but because of these properties, we're able to figure it out. So that's it. That wraps up video 1. Come on back. We'll start talking about triangles, which is an extremely important topic, not just for geometry, but also when we start getting into trigonometry and further mathematics from there. So we'll see you in video, what are we on, 13.